Okay, I've muted all the callers, and again, I'd like to say good morning to everybody. Today's webcast is the third in the series. This is a productivity series where we've been working our way up the value chain, and we'll talk about the value chain in just a minute. In this series of the value chain, we're going to talk about what kind of productivity gains you can see by moving your data from the DWG file-based environment. Maybe it's not DWG, maybe it's shapefile, maybe it's SDF, but moving that into a more central data store that is more of an enterprise approach, more accessible by more people, and putting that into a database of some sort. Today we'll be talking directly to an Oracle database, but this works the same whether or not you have SDE database. So people familiar with the ESRI world will be familiar with an ArcSDE database. SQL databases, MySQL, and then there are also a host of databases out there that support an ODBC connection, an open database connectivity connection. So there's a lot of choices when you start to move into the database world, and Map works very well with a lot of those choices. So here is the value chain, and again, this productivity series that we've been working through in these webcasts, and again, this is the third in the series. We started out at stage one. We talked about AutoCAD, some of the tools that Map gives you in stage two above AutoCAD that you see productivity gains from, things like drawing cleanup, the ability to query and attach source drawings, things of that nature. Last webcast we talked a lot about FDO connectivity and how you can consume many sources of data using this FDO feature data object connectivity. We took a quick look at Map Guide in the last webcast and how you can publish that data out to Map Guide. In this webcast we're going to focus mostly on taking data that has been created, whether it be in DWG, SDF, or shapefile, taking some file-based data and moving that into a spatial database, in this case Oracle. Stage 5, you'll notice is topo-based, where Autodesk has taken the idea of the enterprise solution, the Oracle database, and built functionality on top of that in the form of topo-based, and these topo-based modules that you can then customize to fit your needs. So anybody that has attended a presentation from either Autodesk or PPI in the last year has most likely seen an iteration of this, and I just want to talk to it for a minute. The important thing to notice here is the data is in the middle, and that whether or not that data is in DWG or shapefile or SDF, or in today's case an Oracle database, that data in the middle is accessible to these Autodesk applications through this FDO layer, and you see that thin FDO layer right there around the center. So FDO allows you to connect to that data regardless of what format it's in. Again, moving up the value chain to the point we're at today in a spatial database, very accessible through these Autodesk applications, and it also brings much more value to the organization because many other people outside of the Autodesk world can access an Oracle database and work with features, work with database tables, work with that information and be useful with that information. They don't need to have something that reads DWG or shapefiles or some of these other proprietary things. Oracle database is an open architecture. A quick overview of Map 3D. We've talked about this, direct access to many formats of data. You have obviously all the AutoCAD tools for your precision editing of that GIS data. So whether or not that data is in the DWG format, the shape, the Oracle, you'll see that today. You can work with that data, you can edit that data. So you've got these familiar tools, these AutoCAD tools that you're very used to, and moving into that GIS world is very easy because those tools remain the same. Map can connect to and work with that data. We've talked about data management, directly publishing data via MapGuide Enterprise. We won't see that today, but we've seen that in the past in some of our other productivity webcasts. And then obviously DWF is also a big one, the file-based format that can be viewed with a free viewer. So what's the value of AutoCAD Map 3D? Well, you leverage that CAD trained workforce, and we talked to this a little bit already. So you've got a workforce out there that is very CAD savvy. They understand AutoCAD, they know how it works. Taking the next step into the geospatial world is very easy when you put Map in front of these people, because Map is a very familiar Autodesk AutoCAD type tool that allows you to work with this geospatial data as though it were DWG data. So they have all the same workflows and the same processes. A little bit of terminology today that I want to get out there so you guys understand what I'm talking about as we work through the hands-on here and working with the Oracle database. A feature. A feature is a real-world object, like a utility pole, like a water pipe, like a fire hydrant. Those individual features are defined in this database, and when you define a feature, you set up a data model of that feature. So what type of geometry defines that feature? What type of attributes define that as a real-world fire hydrant, for instance? So your geometry may be a block that you choose to use. It may be some other type of point marker. The attributes on that fire hydrant might be manufacturer. You might have a field for last date maintained, so a maintenance field. You might have a field for whether it's a 2-port or a 3-port fire hydrant. So these things that define that particular hydrant as a real-world object go into the data model of this feature. A feature class is a category of features. So you might have a feature class for fire hydrant, and that feature class is the generic definition of fire hydrant, and then each particular feature that is part of that feature class gets its own attributes and geometry that define it as that particular fire hydrant in the real world. Then you have a schema, which is the next size umbrella. A schema can be a collection of related feature classes. So you may have a water schema or a water system schema. In that schema, you might not only have fire hydrants, but you have water pipes and valves and so on and so forth. So that schema is a collection of all those features that are related to each other, related in the fact that they are part of the water system. And then finally, the data store is the collection of all these schemas, feature classes, and features. So the data store might be something like, you can think on the size of perhaps a city. So you'll have XYZ city data store, and in that city data store you've got all your schemas. So you've got maybe a water schema, a wastewater schema, a land schema that might have all your parcel definitions and zoning definitions, a building schema that has all the buildings. So the schema is very flexible. The data store is the overall umbrella that encompasses all the things for this particular chunk of data that you'd like to keep separate in the data store. So let's jump into Map 3D here and take a quick look. So currently I've got just a blank drawing here, Map 3D 2009. Hopefully you've all seen this in one form or another. I won't talk too much about the interface today. But we've got several sources of data that we've got, and we've talked a little bit about the data model and what goes into it. Well, that data model might be something that already exists. So my Oracle database, for the most part right now, is just a blank template. There's nothing in it. So I'm going to start to populate it with data, and the way I populate it and build these schemas and these feature classes out can vary depending on where I'm starting, what type of data I have right now. So let me open a drawing that's got some data in it. Here we go. Here's a parcel drawing. So this is DWG stuff. We've got just parcel lines here with parcel numbers in them. If I take a quick look at the properties of one of these parcels, We'll notice that I've got an object data table, so that's the way in the DWG environment that you might put attribution, real-world definition on these parcels is through an object data table. And in fact, I've got one in this particular drawing for these parcels. So this drawing, for the most part, has the data model of my parcels. Now, it's not in an open database format yet. It's still in DWG, but Map makes it very easy to move this data into that Oracle environment. What else? I've got some other data out here, some other file-based data, so let me just connect to that real quick. Maybe I've got a shapefile. Let's see what we've got for shapefiles. Here we go. We've got some water lines. So I'll connect to that shapefile that contains a waterline feature class. And here are the water lines. I can zoom up. They show up kind of a green. Let me change that style real quick just so it stands out a little bit. Let's change them from green to a blue. So there we go, a little easier to see those water lines now. So I've got a couple of sources of data, both file-based. I've got some shapefile data. I've got some drawing data. Let's get one more source of data, and then we'll start to move this and copy these schemas, these feature classes, into the Oracle database. So let's get some SDF information here. What do we want? Here's some zoning data. So I've got some zoning polygons in an SDF format. So you see that information lay over the top. Let me just clean this look up a little bit. Move zoning below my water lines here. There we go. And I'll add some transparency so we can see through that zoning data. So here we've got 3 layers of data. We started with DWG in the parcels. We've got waterline information from a shapefile, and we've got zoning information that is accessible to us through SDF. Now, wouldn't it be nice if all this data were in one central location where everybody could access it? And that's the beauty of a database. Now, that's not to say that the database needs to be Oracle. Let's take a look at some of the other database providers. So there's Oracle. We've also got ArcSDE. So those of you familiar with the Esri world know ArcSDE. It's the Esri middleware that sits on top of an Oracle or a SQL database and allows access through the Esri products. MySQL, an open source version of the SQL database. Any database that supports an ODBC connection, an open database connectivity connection, so there are quite a few databases out there that support that. A couple of the big ones that are open source, meaning free to use, are PostGIS, PostGRE. Those are pretty popular in the geospatial world. Obviously the Oracle database connection, we're going to work with that today. Here's SQL Server. So those are some of the databases that you can use. Oracle isn't necessary, although I've got Oracle installed, so I choose to use it. And keep in mind, by no means am I an Oracle DBA or anything special here. Map makes it very easy for me to work in the Oracle environment. So honestly, the hardest part is installing and setting up Oracle correctly, and there's some pretty good white papers and step-by-step on that. So let me add an Oracle connection here. So I'll just call it Oracle 1. I know that my database instance is named ORCL because that's what I named it when I installed Oracle. Login here, so as you might suspect, Oracle has some login credentials. So let me just log into that database. And what am I going to do? Let me show you all the bells and whistles here. So I can choose to show all data stores. So this will look into that Oracle database and see all these data stores. Honestly, the majority of these came with Oracle as kind of examples of data stores, and they've got some sample work built around a lot of these. A couple of these, like TBSys, MDSys, are TopolBase data stores that were built when I installed TopolBase on top of this. But what I want to do right now is I want to add a new data store. So I'm going to start a new data store for the city that I'm working in, and I'll call it Demo City. So you can imagine that this is the data store for the entire city. A password is required, so I'll just add a password here. Don't need a description, but what's important to note is the database, or I'm sorry, the coordinate system, the data store coordinate system. And this is key to making these things work correctly, because when you start to work in the geospatial environment, you want things to be geo-referenced in the real world. And so far, the DWG, the shapefile, and the SDF file that we've got are in the real world, and I should have shown you that, but they're in a California State Plains coordinate system. So I'm just going to mimic that here in my Oracle database. So I'm going to scroll down the list and find California. There it is, Zone 1, NAD 27. So that's the coordinate system I'm going to apply to this. And what table space in Oracle do I want to put this? I'll just put it in the users table space. So there is a new data store being created in Oracle for me through Map. I get a message here that it was created successfully, so that's good. I'll choose to edit it later. So I'm now connected to Oracle. Although it doesn't show up here, there are no layers of data, I've got a blank slate, a blank data store in my Oracle database that I can now start to build a data model in. And as I mentioned, there are several ways to go out about building that data model. Let me switch tabs here. Did I connect to that data store? I believe I did. I didn't. I forgot to choose the connect button. So, one more time, let me log into that. And my data store should be here. Here it is, Demo City. What version? I only have one version. Oracle databases support versioning, so you can have a pending state where people make changes and then it goes through a review process before it gets published to the live database. In my case, I've just got the live database. So I'll connect to that. There we go. That's what I didn't do, was push the connect button. So now, on the Map Explorer here, I see an Oracle connection. Let's take a look at the schema in that Oracle connection. We talked about schemas already and what they are. And because I created a brand new blank data store, it's got just a default blank schema in it. It's got one feature class that really is nothing. That feature class has an ID. This will be system generated. So each object in the database has its own unique identifier, and it's got a geometry, so it can hold some type of geometry. What that is, I don't know yet. But I'm not even going to really use this default feature class. In fact, I might even get rid of it later. But I'm going to start to build out the data model in this Oracle database by first taking some of this data and pushing it into that Oracle database and having that Oracle database schema copy what is here in my drawing. So let's start that process. So I'm going to turn off these two geospatial layers of data that were shapefile and SDF, and I'm going to start by just working with this DWG data. So I'm going to basically take this DWG data and export it into the Oracle database. So I'm going to take a quick look at the layer that these parcel polygons reside on. Also, another quick look at the properties, make sure, yes, I'm getting the object data, the parcel number, and the land value. So let's go ahead and choose to export And you'll notice that Map 3D export to Oracle. So Map and Oracle have a very good relationship, and they work very well together. Now that's not to say that SQL or some of those other databases don't work equally as well. They do, but there's some customized options here for Oracle that make it pretty easy to work with Oracle. So I'm going to export this data right to an Oracle connection. Think about that for a minute while it accesses that Oracle database. So here is the one Oracle connection that I've got. And remember, I left it named Oracle 1. What I'm going to select first, so first I build a selection set of data in this DWG that I want to push into Oracle. So to make it easy on myself, I'm just going to select a layer, a drawing layer, feature classes. I want to create a single feature class. All the objects I selected in this drawing are parcel lines, so I want to create one feature class, and I'm going to name that feature class, let's call it Parcels. It's going into the Oracle 1 database. And what type of geometry in it? It's not a point, line, and a polygon. All this geometry is just polygon geometry. So I'm going to be a little bit smart about how I push this data over, because when you start to work in a database, you want to keep your data as clean as possible. Not that that's not true in the DWG environment, but it becomes very important in the database environment. And then finally, what real-world attributes, what defining attributes do I want to go? I have that object data table called Parcels with the parcel number and the land value. I want to push that data, that attribute data, into my database as well. And then finally on the Options tab, you'll notice we're in a California State Plains coordinate system, and I want to treat all closed polylines as polygons. So let's say OK, and this is going to take just a moment. There's over 32,000 parcels here in this drawing, and it's going to push all those into the database, populate this new Oracle data store with all this geometry and attributes, and thereby building or starting to build a data model for me in the Oracle database. So we'll give this just a moment to crank away here. Getting close, getting close. And keep in mind that I'm running Oracle on a pretty standard laptop. This isn't really a workhorse server like you would expect Oracle to exist on. So some of these operations take just a little bit longer. But still not too bad for pushing almost 33,000 parcels and attribute data into this Oracle database. So there we go, 75 seconds, not too bad. So what did that get us? Oops. Let me jump back a tab here, and now let's take a look at that Oracle schema. You remember we had just a generic schema here. Well, I've got rid of that generic schema, and Parcels is what now exists. What are the parcels? What properties does the parcels have? They have the APN. We got that from the drawing. They have the land value. We got that from the drawing. This feature ID, this is the unique identifier that each and every object in this Oracle database will have. That's system generated number. And then finally a geometry, which holds the graphics, the geometry graphics for this parcel. So we've started to build a data model here for our city. So what if I were to, let's see, let me turn off the layers in this drawing, the APN and the parcels layer, so I no longer see that data. Let's get that data directly from the Oracle database. So jump out to connect. There's my Oracle connection, and look, now I have a schema in that Oracle connection for parcels. We just populated that. Let's add it to the map. So now I'm going to get all that geometry and all that attribute information out of my Oracle database. Again, give it just a second to crank away. So there we go. There is that, all that parcel information now from an Oracle database. Take a look at the data table. So here's the data table for all 32,000 plus parcels, with showing us the parcel number, showing us the land value, and the feature ID. It's grayed out. It's not editable. These other values are editable here. So if I needed to edit the land value of a particular parcel, I can do it here. If I needed to edit the parcel number of a particular parcel, I can do it here. It will update in that Oracle database. So I've got a live two-way connection. I can add data, I can consume data, and I can change data. So pretty cool. So let's continue to build out this data model. We've got some other layers of data here. Let's add the waterline information. So here's the waterline data, again in a shapefile. Let's move that into the Oracle database, and that process is going to be a little bit different. You wouldn't expect to find over here under your DWG commands an option to export a shapefile or push a shapefile into an Oracle database here. But what we do have is we have a tool called bulk copy. And bulk copy is the way that we take these geospatial sources of data and we push them around from one format to another. So I can take this shapefile and bulk copy it into the Oracle database and build a new schema and begin to add to my data model. So let's do that. Let's do a bulk copy here. Where do we want to copy the data from? So the data we want to copy from exists in our shape connection. There it is. It's the water line. Where do we want to copy to? We want to copy to our Oracle connection, the live database, the live version. If I had more than one version, I could choose that here. And you can see what it's doing is it's looking into that shapefile. It's seeing all the attributes, whether or not they're abandoned, the size, the type, and it's pushing that data into the Oracle database. Pretty easy. Coordinate systems might hang up here, so I'm going to ignore coordinate system errors for the moment. And let's just bulk copy that data over. Again, this takes just a moment. There's quite a bit of waterline data that we're taking from shapefile into Oracle database, so it takes just a moment here. There we go. 30,000 plus objects moved from shape format into Oracle. So we can close that. Again, let's take a quick look at our schema. Oh, and I made a little mistake there. I should have renamed that default schema to be something like water system. I missed that, but that's okay. So we've got our waterline feature class here. Again, with these attributes pulled from the shapefile. We can take a closer look at some of these. Whether or not it's abandoned, that's a type of data, a string type. They give length 254 characters, which seems a little excessive to say yes or no on abandoned. And the more frivolous you are with these sizes, the larger your database is going to be by default, sometimes unnecessarily. But the size attribute is a string, and the type attribute is a string. So Again, all this information copied directly from that shapefile. So pretty cool. And again, we also get the geometry. And to prove that out, turn off my shapefile waterlines layer, remove that layer of data. Think about it here. Should be saving this drawing. Anybody who's worked with Autodesk products knows that saving often is a good thing. I'm going to go ahead and fly by the seat of my pants though. So now if we take a look at our Oracle connection, we not only have parcels, we have water lines. Move that data from the Oracle database, display it in our map. So there we go. There are the water lines now from Oracle in our map. So again, very powerful, very easy to move data from one geospatial format, such as shapefile, to another, in this case an Oracle database. You can go from a file base to a file base, so if you have SDFs and shapes and you want to move data back and forth, bulk copy works for that as well. So I've got one more source of data out there that is not in my Oracle database yet. It's the zoning information, and here we see the zoning information. We take a look at the data table. We see that it's got information in it, attribute information that defines this as the real world object that it is. So let's move this SDF file into the Oracle database and copy this schema, put this schema in our Oracle database. Again, because this is an SDF format, we're going to use our bulk copy. We want to copy from SDF. And we want to copy it into our Oracle database, the live version. And in this case, we don't want to put it in the shape schema. Let's put it into schema 1, where our parcel schema exists. So it will create a new feature class zoning under schema 1. And not worry about coordinate system. And let's let that copy. This should go a little bit quicker. There are only 776 objects. We'll take a look at our schema. Our schema 1. We now have a parcels feature class. We have a zoning feature class. Let's go ahead and get this data now out of the Oracle database and build a nice map all directly from the Oracle database now. And then we'll talk about how to manually create a new feature class in the Oracle database, not having something to work from, but creating something from scratch and what that looks like. So turning off the zoning layer that is my SDF, I'll remove that layer. Turn back on my water lines. Turn back on my parcels. And you'll notice, again, things work a little bit slower from that Oracle database, especially on this laptop that I'm working off of. So be aware of that. And then finally, that Oracle database now has another feature class. So let's make a nice map here. Put zoning on the bottom. We'll just take a second here to kind of clean this map up. Stylize our water layer. We like blue. Add just a little bit of thickness. Parcels. Let's go ahead and make those parcels transparent so that we can see through them. So we see the zoning layer show through. And let's do something a little bit nicer with the zoning layer. Let's go ahead, oops, what I want to do. Let's go ahead and theme that zoning layer based on one of the attribute properties of it, which is zone class. So it finds the zone classes in there, and I'll just go with the default color. And I want to delete the original color of that. So there's a fairly decent map based on Oracle data rendered in our DWG environment through the FDO connection, and then stylized to look somewhat nice. So pretty easy to take sources of data like DWG, like SDF, like Shape, and move that data into an Oracle database, thereby creating, for lack of a better term, a data model in this database. But what if we have something, let's say for instance we want to add a feature class that is valves. Say we want to add some valve information for this water line. We don't have any existing data that we can bulk copy or export in and create that for us. We need to create that on the fly. So let's go ahead and do that. Let's edit the schema in this Oracle database. And again, had I been paying a little better attention, this default schema would be called something like water system. This schema 1 might have been called land, or something along those lines, to be a little better definer for what type of information we expect to find in it. But I didn't, so I'm just going to go into default, and let's add a new feature class under our default schema that is valves. So I'll just choose new feature class. I get to give it a name. Let's call it valve. A description. This is not necessary, but sometimes helps. Water system valves. And then in this feature class, 1 valves, I need to add some properties for it to be valid. It needs to have some properties to be a valid feature class. So let's do that. So property 1, what do I want to call this? What are some of the things we might track on a valve? Maybe a type. What type of valve it is. And what type of data is this going to be? Is it going to be data, attribute data, geometry, an object, or an association? Well, in this case, we want to track some type of data here. What type of data? Let's see, let's make the type a string. What length? Let's see, I think 32 characters should be enough to define what type of valve it is. We can also add some constraints. Let's say we want people to not be able to say what, make up their own type of valve. We want to constrain them to several types of valves that we use in our water system, and then have them choose that from a drop-down list. We can do that. Let's build a list here, and let's put some values in this list. Let's see, there might be a gate valve or a butterfly valve. Also ball valve. So those are 3 types of valves that we want them to be able to choose from, not make up anything on the fly. So we put that list together. Okay. Let's see here, back to valve. Let's add another property. We need to have a unique identifier here, something that the system can auto-generate a unique number for. So let's do that here. Let's call it feet ID for feature ID. This is going to be type of data. Let's make it a string. Unique. Let's give it a length of, let's see how long, 256, okay. So I'm missing something here. Okay, I think this will work. So there's the type of feature ID. So let's go back to valve and say feature ID is the unique identifier for that. So we've got valve type, we've got a unique identifier. What are we missing here? We're missing something to hold the graphics, the geometry of this. So let's add one more property, and let's make that, I'll stick with their naming convention here, call it geom. What type of data is it? It is a geometry. And now we get to choose what type of geometry can fit into this. We don't want all 7 types of points, curves, surfaces, polygons, blah, blah, blah. This is just a point. All these valves are just point types. So let's make it point. You can add elevation, so on and so forth. But let's go with that. Let's see. Okay, so we built a valve feature class from scratch. Let's see how we might use that. So from the display manager here, I'm going to again take another look at an Oracle database. Look, there's valve. We just built that, although there's nothing in it yet. It's a blank feature class. I can still add that to the map. There's valve. It finds a default point marker. And now let me toggle off some of this other data here. So we just see water lines. And you can imagine that at these connections there might be valves. So how might I add a valve? Well, let's do it like this. I'll just right click on that layer, choose create a new valve. Alright, where am I going to put it? Let's put it right here at that intersection. So I'm working with an Oracle database through Map 3D, and these tools, you know, my snaps and all the AutoCAD things that you would expect work. Here the data table pops up for me automatically and says, hey, you added a new valve. We need to add, and look, here's the cool thing. Under my type, there are the types of valves I specified. So let's say it's a gate valve. So feature ID, you'll notice is not filled in yet. But when let me go ahead and close this and check this data in, so I'll check that feature in. That at that point is when it updates the actual database, and I'm getting a little error message here. Does not save the target feature source. I'm wondering why not. So I might be doing something. I might have missed something here. Let's take a quick look. Oops. Got this valve. I might have done something wrong here. Let's try that one more time. Create new valve. So gate valve. Let's check those features in. So I missed something here. Failed to publish. Let's take a quick look back at the schema. It's a type. String should be okay. Well, I can't see it right off the top, but I've missed something here. So, at any rate, this is the basic process that you would go through to build a schema, and then once you have that schema built, you can connect to it and work with it here. So for some reason it's not filling out my feature ID, which should be system generated, and I can't see it right off the top here, but I obviously missed a selection there somewhere in building that schema. So we'll just let that slide. Um, but that is how you would, the several methods you would use to build out a data model in this Oracle database. Let's see, I'm going to go ahead and unmute the phones now. We're getting up to about the end of the demonstration. I want to have some time for questions here. So let me go ahead and unmute the phones, and I'll entertain any questions that might be out there. Okay, so everybody should be unmuted. Anybody out there with a question? Maybe everybody's not unmuted. There we go. There we go. Now I can hear people. Oh, yes, go ahead. Yeah, you'll notice it's grayed out. If I wanted to rename it now, I would have to go through the Oracle Database Control. I could do that outside of the map environment, but once it's been added in map, I cannot. You'll notice it's grayed out, so you'll want to be a little bit careful about your naming convention, but it's not set in stone. It can be changed through the Oracle Database Control. Anybody else with a question? Okay, go ahead. I know of several organizations that have been successful connecting via SDE through to a SQL database. I don't know that I don't know that it's been SQL Express. Um, there are no patches that I'm aware of. These tools for connection that we're looking at here, these FDO tools, they are an open source set of tools that you can go to the fdo.org site or osgeo.org, and there may be some more information for you there. But I don't know of anybody that's connected via SQL Express and SDE, and there are no patches that I'm aware of either. But if there were, they'd be available on that osgeo.org website. Mm-hmm. Anybody else with a question this morning? Okay, well let's finish up here. So we've gone through questions. Again, I'd like to thank everybody for attending today's webcast, and if you would, please watch your email for a survey regarding today's webcast. It gives us valuable feedback, and it also allows you to steer future webcasts. So please be aware of that. With that, I will go ahead and end today's meeting. Again, thank you everybody for attending, and I hope to see you next go around. Goodbye, everybody.